So today's video we'll talk about derivatives where we'll be differentiating polynomials. We'll use the product rule, the quotient rule, the chain rule, trig functions. We'll do a lot of things, so kindly stick around and learn one or two things. So without wasting much of the time, a derivative is simply a function that gives a slope at a certain value of x. So for instance, you're given a function and then you're told to find the slope at x equals to 2. You say divide x of this. So in order to differentiate this, we use the power rule where the power drops and multiplies with the coefficient. So when it drops and multiplies with the coefficient, we have 6x to the power 2, and the power reduces by 1, by the way. And then when it drops, we have 8, and then reduces by 1, we have a 1. And the power drops again, we have 3 by 1. Then the derivative of any coefficient is simply 0, no matter how big the constant is. So we have, since we are trying to find the gradient at x equals to 2, so that is 16 plus 3. So we have 24. So that's 43. So this is the gradient at x equals to 2. Yeah, so simply these are basics where differentiate a polynomial. When differentiating a polynomial, you have to use the power rule. The power drops, multiplies with the coefficient, and it reduces by 1. So that's simply it when differentiating polynomials. Let's go further and talk about the chain rule. So for instance, you're given a function like y equals to x minus 2 to the power 5. You could simply expand this and use the method that we are from using, but that would take rather much time and space. So there is a much simpler method to use where we say let the inside function be equals to x minus 2. So if we let the inside function be u equals to this, meaning we can also say y is equals to u to the power 5. And then we can differentiate this with respect to x and differentiate the second function with respect to u. So we find du dx will have a 1. Then we find dy du will have 5u. So we have the two derivatives. So in order to find dy dx, we can say dy dx is equals to dy du times du dx. So dy du is simply 5u to the power 4 times du dx is simply 1. And then we get something like this. We can replace u with our original function, which is that. So this is the derivative using the chain rule. You can use a shortcut method where you say the derivative is equals to this power drops here, and then you differentiate the inside part, we get the 1, and then you write this part the way it is, and then the power drops by 1, 4. So y prime is equals to the same as what we got here. So we move on and try a tutorial sheet question. So what we are given is y equals to 15x squared plus 1 to the power 7. So as I said, we let the inside part be equals to u, can be any letter, but just prefer u, don't know why. So we differentiate this with respect to x. So it will be 30x. Hope you know how this is done from the first example, where the 2 drops multiplies with the coefficient and the index reduces by 1. And then I said the derivative of any constant, no matter how big or small it is always 0. And then since we let u be equals to the inside part, we can say y is equals to u to the power 7. So differentiating that with respect to y, we have 7 to the power 7u to the power 6. So dy dx is now du dx times dy du. Du dx is 30x times du dy, which is 7u to the power 6. 7 by that is simply that. We have to 10x. Then we replace u with what we had. What did we have? Oh, we had that. So this is our first derivative. Can you say dy dx is equals to that? Okay. So without wasting much of time, we'll do the product rule as well. So from the word product, simply a multiplication of 2 functions. So for example, we are given a function like like I said in general, we can multiply and use the power rule, but that would take time when we're given functions that have extremely big powers. So simply can say let u be equals to the first function and let v be equals to the second function, and then differentiating this we have 2x, and differentiating that we have 4x. So dy dx is equals to v u prime plus u v prime. So this is the formula for the product rule. So what is our v? 2x squared. Our u prime is 2x plus our u, it's x squared plus 1, v prime 4x. So we can multiply that, we have this, and then there we have 4x like terms. Yes. So this is 8x plus 4x. Can end here, or I can say plus 1. So this is our dy dx. So we'll try a tutorial sheet question as well. Product rule, where we have f of x is equals to x to the power 3 plus 2 x to the power 5. So say let u be equals to the first function and let v be equals to the second. So differentiating that, we have 3x to the power 2. Then we can rewrite that as x 1 over 2 v. And this is, and then to differentiate that we can, But to differentiate that, we drop the index and x 5 minus 5 over 2 minus 1. So 5 over 2, then 1 is simply the same as 2 over 2. So that's 3 over 2. So we can write this again as 3 x squared. So now back to our formula, we'll say f prime of x. In this case, we're given of x, so we'll say f prime of x is equals to v u prime plus u v prime. So what is our v? Our v, we'll use the original, so power 5. What is our u prime? 3x squared plus u is 2 v prime 5 over 2 x to the power 2. Yeah, so I think we leave it here. Yeah, it's okay if we leave it here, but if you can simplify, try as much as possible to simplify it. So I think for this video we'll only cover up to the quotient rule, then I'll come back later with part 2. So lastly, let's look at the quotient rule. Quotient simply division of two functions. So for instance, you're given u over v, where u is a function and v is a function. The formula to use is divide x is equals to v, the denominator, multiplied by u prime minus u, the numerator, multiplied by v prime divided by the denominator squared. So this is the formula to use. You notice we have a minus sign here. So this is the quotient rule. The quotient rule will go directly to Taylor's equation, which is y equals to 3x squared over 2x minus 1 squared. So say let u equals to 3x squared and let v equals to 2 minus 1 squared. So differentiating that, we have 6x, and differentiating that using the chain rule, said the power drops, you differentiate what's inside, you write that function, and then the power drops by 1, and then that we have 4, like that. So I think we should write it like this. So this is our v prime. So from the formula we have dy dx is equals to v u prime minus u v prime over v squared. So what is our v? Our v is simply that 2x minus 1, and then our u prime is 6x minus our u is in v prime 8x minus 4 divided by v is 2x minus 1 to the power 2. So I think we won't go far with this, but if you have to simplify it, okay, I think we'll try to simplify it. So we'll multiply 3x squared with that, we have 24x to the power 3 plus this negative, and this negative gives us a positive 12x squared over 2x minus 1. Then we'll leave the down part like this, and then we'll expand this. Well, this is simply as writing 2x minus 1 two times, but we'll say 2x to the power 2 plus 4x squared, then 2 times 2x is 4x times negative 1 is negative 4x plus 1. Running out of space, so I'll continue on top where we'll say 6x times that we have 24 x to the power 3 minus 24 x to the power 2 plus 6x minus 24 x to the power 3 plus 12 to the power. Then we'll write the denominator as it is. So these will cancel, negative and positive. And then we'll remain with negative 24 plus 6x. Oh, just notice something. These are like terms, so we'll have 6x minus 12. So this is our final answer. This is our dy dx. So thanks very much. That's basically it for this video. And you've probably noticed that I'm using u prime and v prime. If you want, you can instead of using u prime, you can say du dx, or instead of saying v prime, you can say dv dx. So yeah, some of you are probably used with this notation and not the u prime, but simply one and the same thing. Yeah, thanks very much. Come back with part 2. I would do with trig and other complex derivatives. Thanks very much.